Binomial distribution. Okay, so when you're working binomial problems, there's three numbers that you're going to pay attention to. There is the probability of success, the n, which is the total number of people, and then x is called the number of successes. Okay, so like here, the workers' union at a particular university is quite strong, about 96% of all workers. Okay, so I'm guessing that's going to be my probability of success, so 0.96. Employed by the university belong to the workers' union. Recently, the workers went on strike, and now a local TV station plans to interview 5 workers at random at the university to get their opinions of the strike. What's the probability that exactly 2? So these are the 3 numbers that we're looking at. So we have 5 total people we're looking at, and we want to know exactly 2. So that exactly is going to be needed by us. Sometimes it's less than, sometimes it's greater than, sometimes it's exactly. All right, so the way a probability experiment works is there's 4 things that have to happen. We're going to focus on 2 of these things. So the 2 things that a probability experiment have to happen are you have to have a set number of trials. Okay, we have a set number of trials, and 2, there has to be a clear success and failure. Okay, so here we have a set number of trials because we're going to choose 5 people. So that's it. We're choosing 5 and we're done. There is a clear success or failure because they either agree with the strike or they don't agree with the strike. Okay, so it's either yes or no. So a lot of times these questions are just yes or no questions. The other 2 that they have to be is they have to be independent and they have to have the same chance of probability each time. But we always kind of stay like that. We only deal with independence in this class. So those are the 2 ones we focus on. So we are going to go pick a person and say, okay, yes or no, do you agree on the strike? Pick another person. Yes or no, do you agree on the strike? We're going to do that 5 times, so that's our set number. And what's the probability? Exactly 2 of those people say yes. So if you ask 5 people, you could get all 5 say yes. You could get 4 to say yes. You get 3 to say yes. You get 2 to say yes. You get 1 to say yes, or you get 0 to say yes. So we want to know what's the probability that exactly 2 say yes. Okay. If it said less than or equal to 2, what we'd have to do is figure out what the probability that 2 say yes. What's the probability that 1 says yes? What's the probability that 0 say yes? And add all those up. But our calculator is actually going to do that for us. That is probably what is the part that's a little bit confusing on here, is the way the calculator is set up. I'm actually going to come back to this problem because I think it's actually easier to do the advanced ones first, which kind of sounds strange, but let's go look at the advanced one real quick and I'll kind of show you this and give you another breakdown. So let me get to it. All right, so in binomial problems advanced, a new surgery is successful 75% of the time. If there are 7 such surgeries that are randomly sampled, what's the probability at most 5 of them are successful? All right, so we have our probability of success, which is 0.75. Don't forget to write it as a decimal. We have our total number, which is 7. We have our number of successes, which is, what's it say, at most 5, okay? So this says at most 5, so what we're actually looking at is there can't be any more than 5, right? So this is actually going to be less than or equal to 5. So if we go back to like thinking about our chart, if we're picking 7 total, we could pick 7. 7 could be successful. 6 could be successful. 5 or 4 or 3 or 2 or 1 or 0. So if we're going to go look at 7 surgeries, somewhere between 0 and 7 of them are going to be successful. But this problem says at most 5. So what's the probability that we pick 7 and we either get 0, 1, 2, 3, 4, or 5 that are successful? Okay, so the way our calculator sets up, actually, this is why the advanced ones are a little... It has a button that looks like this. Okay, so the way it sets up is it has this less than or equal to. That's why it makes these a little bit easier. Okay, so there's 3 blanks here. So the 3 blanks are the 3 letters that we're using. The first thing that goes is our N, our total number of trials. Then our P, the probability of success. And then up here is our X, our number of successes. So like I said, since this has a less than or equal to, this is where we're going to do at most, or if it says less than or equal to. All we're going to use is this calculator, and it's actually going to go through and add up what's the probability we get 5 out of the 7, or 4 out of the 7, or 3 out of the 7, or 2 out of the 7, or 1 out of 7, or 0. So it's going to add all those up and just give us our answer. So there's no subtraction or anything we have to do. We'll do one of those next. Let's go back to the calculator and see how this works. All right, so we click this button right here. The first thing that goes in there is N, so you put a 7. The next thing is the probability of success, so 0.75. Make sure you do a decimal. And then at most 5. Okay, so again, the less than or equal to 5 is the same thing as at most. So if I press equal, I get 0.55505. What do we want? At least 4 decimal places, so we can just change that to a 1, and we should get our answer. All right, so if it says at most 5, or you're less than or equal to, you don't have to do any subtraction or anything in the calculator. If you get one here, so this one says more than, skipping ahead here, I guess, the manufacturer of fertilizer guarantees that with the aid of the fertilizer, 80% of the planted seeds will germinate. Suppose the manufacturer is correct. If 10 seeds are planted with the fertilizer or randomly selected, what's the probability that more than 8 of them germinate? All right, so our probability of success is 80%, so 0.80. Our total number is 10, and our number of successes is 8. Okay, but we want more than 8. So let's think about this. This is greater than 8. So on our chart, and it doesn't hurt to draw this out and think about this, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. That's all our possibilities. If we're going to randomly pick 10 of them, then 0 could germinate, 1 could germinate, 2 could germinate, all the way up to 10. So we want more than 8. Well, more than 8 would just be 9 or 10. Okay, so here's where it gets a little bit tricky with the calculator, since our calculator defaults to less than or equal to. What we got to do is figure out what number to put in our successes. These numbers are never going to really change. They're going to be the N and the P, 10 and 0.8, okay? So we're going to put those in there. But we got to figure out, since it says more than, we just want the 9. So since the calculator always is going to give me the less than or equal to, we kind of find out the opposite of that, or the complement of that. So if we just want to know what the probability we get 9 or 10 of them to germinate, then we could find these. We could say, let's find less than or equal to 8, and then take it 1 minus whatever our answer is, and that would give us this side. Okay, because all the probabilities, remember, all probabilities add up to be 1. This is all my probability possible from 0 to 10. So if I figure out what the yellow box is and then do 1 minus that, that should give us how much is in the blue box. All right. So now we come over here and we could do, I'm going to go ahead and do 1 minus, use a little binomial formula here. So we have n, which is 10. A probability is 0.80. And then we are going to do less than or equal to 8 because we just want 9 or 10. And that should give us our answer there because we did the 1 minus, which is just going to give us the other side. Oops, 7, 5, 8. All right. Oh, I didn't put a 0, so it's yelling at me, but that's fine. All right, so now let's go back to the basic, and hopefully it's that same problem that we were just doing. It is. All right, so on this one, this time we have the exactly 2. So just to refresh over this problem, because it's been a minute, where the probability is 0.96, the n is 5, and the x is 2. So it says exactly 2, so we just want 2. So on our little chart here, all we want is exactly 2. So again, to me, this is harder than the advanced one because we got to do a couple tricks here. Remember, our calculator is going to give us this, okay? So again, the n and the p don't change, so we can go ahead and put those in. That's 5, and this is 0.96. But we want to change this less than or equal to exactly. So we're going to have to think about this for a second. So we want exactly 2. The calculator gives us less than or equal to. So we're going to have to do a couple things here, actually. Less than or equal to, so we could do less than or equal to 1 and get this side of it, right? So what if we did less than or equal to 2 and then subtracted this part, found our answer for the less than or equal to 2 probability, subtract the less than or equal to 1, and that should leave us what the extra is here. So again, think about it like on a number line, 0, 1, 2. If I figure out what this part is, and then I figure out what this part is, and I subtract them, that leaves me with just this area right here, okay? So we're actually going to have to find two different ones right here. And again, all right, so I can actually do this all in one swoop. So I can do the less than or equal to 2 part first, so 5.96, then 2, but then I can go ahead and do minus 5. Again, these aren't going to change. 0.96. And then 1. And that should leave me with just that area of 2. And that is correct. So again, my advice to you is almost to go to the advanced ones first, because I almost think they're easier than the basic ones.